from probability, right? So far in probability, we talked about, just really basic probability. And then the next day, we kind of talked about there's a difference between theoretical probability, excuse me, and experimental, right? So we said theoretical was like, in theory, it should be this often. And with theoretical, not every event can have a theoretical probability. Everything can have an experimental. Well, I shouldn't say that either, because it could be something that we haven't done yet. Like, we can't do the experimental probability of flying a human to Jupiter because we've never done that before, and there's no way to like test that probability, right? So we couldn't. We can't always do experimental, and sometimes we can't always do theoretical. For example, the other day, I don't know if we have it on here. Yeah, we do. Here on the screen, you can see we had Danae that was taking shots at a dartboard. There's no theoretical probability there, right? We can experiment and say, okay, Danae, we want you to take, throw a dart at the board 100 times and see what the probability is that you'll get a bullseye. But not only are there a lot of factors involved, there's no way to, she's not a robot throwing arm, so it's not like there's a theoretical probability. Not like flipping a coin where it's like, oh yeah, it's going to be heads. If it's probability of heads is going to be 1 out of 2. That's something that could be theoretical because something could be analyzed, whereas a person's throws, you can't really have a theoretical probability, but you could have experimental. Excuse me. All right, so we talked about kind of the differences between those two. And yeah, and we're going to look at our experiment that we did the other day in just a moment. But the last day on Monday, we talked about making predictions from probability. Okay, and so we said, this is just kind of a reminder here, theoretical probability, it's, what is the likelihood on the next try? And how many times would you expect in a number of tries? And so we said, likelihood on the next try is going to be the same. If we're putting the socks back, like on this one we did the other day, if we're putting the sock back, theoretical probability is just going to be the probability of that next try. So if it says, she picked out, she pulls socks out 50 times without looking and records her experiment. Okay, and she had all these results. Based on those results, excuse me? Ooh, I don't know what's wrong with me today. So, but based on those results, she can say, and I know these boxes are in the way. Here. There we go. We can say, all right, well, she drew 50 times. We don't necessarily know how many black socks there are, right? We don't know how many socks are in the sock drawer, but when she pulls it out 50 times, pulls the sock out, records it, puts it back. Pulls the sock out, records it, puts it back. If she does that 50 times, 17 of those times she got black. So from experimental, experiment, she got 17 out of the total 50 times, right? So she can then predict, okay, 17 out of 50 draws will be approximately 33.3%. Okay. Okay. Sorry, I know this is a little messy. And then we looked at a different one, and this was a different problem. It says Nancy has a drawer of different colored socks. She has 4 reds, 3 yellows, 1 green, 2 blues, 2 purples, and 6 black. How many times do you expect Nancy to pull out a red sock if she pulls socks without looking from the drawer after 200 times? So I want you to look at that. Again, we talked about that one the other day. And so we're basically saying, all right, if she has a 4 out of 18 chance, right? If there's 18 total socks and she has 4 of them are red, then she has a 4 out of 18 chance to draw a red sock, right? Now if, yeah, let's go ahead and leave that for now there. Thanks, have again. You'll have to make a copy on that. Then if she does it 200 times, then if we multiply the probability, the 4 out of 18 times 200, it'll tell us how many reds she'll draw if she does it 200 times. That makes sense? So predicting the frequency of an event is really not too bad. As long as you can get the theoretical probability, then you can just multiply by how many times you do it. Okay? So those were the two that we looked at yesterday. One was you take the probability, if you can figure it out, and then multiply by the number of tries. So 44 out of 200 tries, she'll get red. And then the likelihood was the other one, okay? And that was taking, I'll put this up here. And that was, even though there was an experiment done, the event can be predicted with theoretical probability, okay? So noticing that she has a certain number of socks and the likelihood of that. Okay, and then we did kind of practice with that. We talked about experimental just a second ago with Danae throwing the darts and saying how you can't necessarily have a theoretical probability, but you can have a experimental because she can throw bullseyes, right? And it says, you know, if she observed from her first experiment that she got 20% of her shots bullseyes, how many times would she hit the bullseye if she throws 200 times? And again, if we're predicting, then we can just take that probability we already found and multiply it by the new number of throws, okay, 200 throws. Alrighty, so let me pause just one sec. Pull that up there. Okay, so now what I want you guys to do here is, let me pull up, sorry, I had it the other day. The first thing I want you guys to do is say if there is a, I'm trying to think how to phrase this. If there's an experimental probability and theoretical probability for something, for example, let's go back to rolling a die, okay? And we roll our die 10 times. I'll write this in the chat too. If we roll the die 10 times, what is the theoretical probability of rolling a 5? So if we have, you take the probability of rolling a 5 one time and then you multiply it by however many times you're rolling, okay? So if we roll a die 10 times, what's the probability of rolling a 5? Or how many times will we roll a 5? I should say that. And if, oh yeah. And I'll scroll back up here in case you want to see this again. Okay, so you're using this pattern here. You can see my mouse. This pattern that we used with the socks to predict with rolling a die. Okay, so I want you guys to think about that. Take about a minute. And I want you to predict about how many times will you get a 5 if you roll a die 10 times. And then we'll talk about it in 1 minute. Pause there so you can work. What do you guys think? Hold your answer if you find your what you think the answer is. Don't say the answer until after the minute. Okay, about 20 more seconds. Hopefully you guys are getting close. Yeah, that was pretty wild, Gabriel. I felt it a little bit. Not as heavy as the past ones. All right. All right, guys. So, what did you guys get? Hopefully, that means that you guys are finished. So, if we rolled a die 10 times, right? What's the probability or what's the likelihood of rolling a 5? How many times would we get a 5 out of those 10 rolls? What do you guys think? Yep. Thank you. Let's make sure we're staying on task, guys. All right. We will have time to talk at the end, but I want to make sure we're on task. Okay, I've got two out of the 10 times, maybe. Good. Got a couple others. Good. All right. All right. I'm assuming that's 2. Good. All right. So let's check it out. So the probability of rolling a 5 just by itself, right, would be 1/5. So if we then have 10 goes, right, 10 rolls, we would say 1/5 times 10, right? Which would then give us 2. So good job, guys. It would be 2 times out of 10 would be the theoretical probability of rolling. Oh yeah, did I say that? I said that wrong, didn't I? 1/6, right? One possibility out of 6. Oh, you're right. Sorry. So 1/6 because there's 6 sides on a die, right? Then multiply by 10 for the 10 rolls, and you'll get 1.66. Okay, so approximately 1.67 times. So we would round that up maybe to 2 times. Okay. Good point there, Preston. Exactly. And Briggs, good job. Yes, so it would be 1/6 because that's the probability of it happening. So we would maybe round it up to 2, but it's the actual theoretical probability is 1.67. Okay, so not necessarily as definite to 2. Great job, guys. All right, so now this is what I want to kind of ask you guys. The theoretical probability of rolling a 5, right? We said would be 1/6. But sometimes it doesn't always work out like that. Like if I had you guys roll a die 10 times like we did before, then you might not get 1.67, right? You can't, that's not even possible. You might get 2, or you might get 1 5, or you might get 3 5s or 4 5s, right? So the actual experimental probability could be different. So I want to show you guys what you did the other day. I know it's been a hot second, but here is the results of the experiment we did. So you guys remember we did a coin toss, right? I'll color these. We did a coin toss, a die toss, and a spinner, right? So, and on those we said, this was a 1 out of 2 probability, right? 50-50 chance. You guys just told me that die, rolling a 4 on a die or any one number is going to be 1/6, right? So this one should be close to 50%. This one should be close to 1/6. Okay. And this one should be close to 11.11%. This was, I think there was 7 people on this spinner. So I want you guys to notice this. What do you notice between the periods here? This is the results, by the way. So like all the first period math classes together got this. All the second period math classes got this percentage. This one got, third period got this percentage on average with their experiment. This one was for heads, rolling 4s, and for spinning the name Cole. So what do you guys notice here? Is there a pattern that you notice between these numbers and the theoretical probability? I want you guys to put that in the chat. What do you guys think? Do you notice a pattern? What do you guys think? Don't be shy. No penalty, right? What do you guys think, though? What do you notice here? Okay, good. I got some that said they're similar. Someone else said that they're all kind of in the 50s and high 40s. Good. Let me get a couple more real quick. A couple more responses. Thanks, Preston. Thanks, Jocelyn. Excellent. Any other patterns? What do you guys think? Okay, they're all similar to each other. Good. Yeah, good. You guys are noticing basically a pattern here. They're all very close to this theoretical probability, aren't they? Okay. Now, you guys know that, like, if I said I'm going to flip a coin, you know that the probability of landing a heads would be 50%, one out of 2. But some of you guys, when you guys did that experiment, this was like last week, when you flipped the coins and you did your 10 flips, some of you guys were like, I got seven heads on those 10 flips. Some of you got like, I only got 2 heads out of the 10 times that I flipped the coin. And some of you said, I got 5 heads when flipping the coin 10 times, right? So it fluctuates a lot. But here's the thing, guys, the more that you do, like if I had you flip a coin 10 times, it's gonna be kind of close to 50. Let's see what I show you guys here. If I have you guys flip the coin 10 times, maybe you get, I don't know, maybe 35% of the time you get heads. That's not exactly 50, right? But then the next time you do it, I have you do 50 flips of a coin. And then you get 40% of the time you get heads. And then I have you guys do 100 flips of a coin, flipping a coin 100 times. And you say, wow, okay, I got 48% of those flips were heads. So if you look at this pattern here that I just drew, guys, this was for, and I'm just making this up, but this was if you did 10 coin flips. This was 50 coin flips. And then 100 coin flips. So if you notice, they'll get closer and closer to your theoretical probability. That's what I'm trying to show you guys. Is that if you look over here, when you did your own experiment, it was maybe kind of close to 50, but not exact. But look how close we are, guys. 52.4, 46.1, 51.4, 49.2. And altogether, averaging all these together, we got 50%. So we hit the mark. Okay, so the more times you go, you do an experiment, the closer and closer you'll get to theoretical probability. Okay, the same for the die roll. This one was 21.7, 20.9, 23.3, 17.0. On average, it was 20. That's pretty close to our 16.67. And we only rolled 10 times, right? And then the spinner, same sort of thing, right? on average, we were very close to our theoretical probability. This is our experimental probabilities, and this is our theoretical. All right, so I just wanted to show you guys, that was the reason that we had you guys do that experiment, is because we wanted you guys to notice that, oh, okay, the more times you do the experimental probability, the more precise your answer will be, your results will be, okay? So good job on that, guys. All right, so now, so we know that experimental probability, the more repetitions you do it, the closer it'll be to the theoretical, if you can figure the theoretical one out. We talked about predicting, making these predictions based off of results. And so now what I want to do with you guys, go ahead and open up a separate tab and open up IXL. We're going to do just one of each of these types of problems that we assign you guys on Monday. Okay, if you guys are not all the way done with those, that is okay. I would always recommend you try to do a day of or the next day, so that would have been Monday or Tuesday. But I want to make sure that we maybe do an example of each of these types of problems so you guys can see that. All right, and I'm doing too much talking, so I'm probably gonna have you guys help me out here a bit too. But once you open up IXL, I want you guys to go to GD5. So let's see. Okay. Yeah, I want you to go to DD5 first. Okay. And I'll give you guys about a minute or so to get that pulled up. Alrighty. And I'm gonna open up a little notepad that I can draw on so you guys can see. So this is where you guys can use your pencil and paper if you need it. All right. So let's say we look at this problem that I've got here, okay? On the last day of Shakespeare class, an English teacher asked her students which play they liked the most. Out of the 12 students who have submitted responses so far, 6 liked Hamlet best. That's a famous play. Considering this data, how many of the next 20 students to respond should you expect to prefer Hamlet? So I'm just going to draw what we saw here. They said out of 12 students that submitted their responses so far, 6 of them liked Hamlet best. Right? So that's 6 over 12, which is what does that simplify to, class? You can put that in the chat. 6 out of 12 said that they liked Hamlet the most. We could also say that is what? Good, got a couple responses. Anybody else? What do you think? 6 out of 12. Good. All right. Good. It would be 1/2, right? Yeah. Good job, guys. Thanks. Thanks for doing all different things. I know it's hard to answer on chat and have this open. Good. 6 out of 12 or 1/2, right? Or as a percentage, we could say that's 50% exactly. All right. That's how many so far. And then we now want to predict, okay, out of the next 20 students to respond, how should you expect them to prefer? How many of them should we expect to prefer Hamlet? Blech. It's a mouthful. We take our 50% or our half, and what do we do with that, class? Once again, I'm going to have you guys help me with this. We take our probability And what are we going to do with it? How do we figure out or predict how many of the next 20 will prefer Hamlet? Okay, good. I got one response. A couple others. What do you guys think? 0, 2, 3, 4, 5. Good. I got here multiply. Some say multiply by 20. Anybody else? What do you think? Great responses, guys. Thanks for responding. It helps you remember, and it helps you make sure that you're following along and getting things right. Okay. Good. Good, guys. So we take this probability and we multiply it by the number of students, the next students. So there's 20 more, so you guys are exactly right. I could, if I want to write this as a decimal, I would say 0.50 and then times 20. Or I could multiply by the half, right? Either way, it doesn't matter. It's the same thing, right? So I could also say times a half. Okay, either way, half of 20, that's going to, you could say 20 times 1 is 20 and then now divided by 2. Or just say this is going to take half of 20, which gives us 10. Right? So 10 of the next 20 students we can expect to prefer Hamlet. That's our prediction, right? It's not exact. Someone might not want it that way, but we figured it out. All right. So, and then this one would work kind of the same way. On the game board spinner, Reed won a prize on 4 out of 20 spins. Based on experimental probability, how many of the next 15 spins should Reed expect to win a prize? So you would then, again, get 4 out of 20 for this guy for his spinning of a spinner. And you would say that's 1 out of 5, right? Try to stay on task for now, Abigail, okay? So we got 1/5, and then you would multiply by the next number of spins, 15 spins, okay? So that was how to do DD5. And again, if you haven't finished these, today you can kind of still try and make sure you get to 80 on this, okay? All right, so let's go ahead and look at the next one, sorry. All right, so that was DD5. So DD6 would look something like this. After this one, guys, we're going to do a little activity game together. But I want you guys to check this out. All right, so this one now says make probabilities using theoretical probability. Okay, so what am I going to do this time, guys? It says if I roll a 6-sided die 6 times, what's the best prediction possible for the number of times you will roll an even number? Okay, so my question to you guys in the chat, I want you guys to go ahead and say how many, what's the probability of rolling an even number on a die? It's probably rolling an even number on a die.
Grilled cheese.
I want you guys to go ahead and put that in the chat. One sec, guys. All right, again, I got a couple responses here. Thanks, Preston, Jonathan, Mr. Howe. Thanks for joining us. All right, a couple more. I've seen a lot of 50%. Good. You guys seem pretty confident in that. It's a good sign. Let's check it out. All right, and if you're still getting your answer, that is okay. But yes, so far, get some of this out of the way. Yeah, the probability of getting an even number. So we've got 1 through 6, right? So 2, 4, and 6 are all even numbers. So you're right, it would be 3 out of 6 or 50%. So now we say, okay, if we roll a 6-sided die 6 times, how often can we expect to roll an even number? Okay, so what is the best prediction possible for the number of times you'll roll an even number if we roll it 6 times? What do you guys think? Okay, I've got one response so far. Thanks, Preston, for being so active today, participating. Great job. Thanks, Pablo. Good, guys. Excellent. Yep, you got it. 3 times out of the total possible 6 rolls would likely to be an even number. And so here's the difference between these two, guys, between these two prediction types of problems. It's really just one is based off of theoretical. Like this one we said, theoretically, it should be half of a die is an even number, right? We know that. So that's 3 out of 6, and then we use that. The other one was just, hey, he asked 20 of his students about Shakespeare, right? So he asked them and then got their results and then asked more people. So one was based off of what we know about a die, and the other one was based off of an experiment so far. So great job, guys. That would be correct, and so we can even put that in there. Oh, it reloaded. That is okay. All right, but it would have said correct. So what I want you guys to do now, we're going to try this out. I know we haven't done this thus far. We are going to do a little Kahoot. Okay, so I have created a Kahoot here that I want you guys to try. And it just starts with basic probability. So this is not even necessarily making predictions on all of these. Some of them are just really basic. What is the probability of this happening? So we kind of want to make sure we're caught up and see how you guys are doing on that. So I'm going to go ahead and see, make sure I got this right. I'm going to go ahead and share my screen. You guys to go ahead and go either open a new tab to kahoot.it or you can use a phone. Either way you'd like. Awesome. Good job, Jonathan Cadence. First one's in. Ref. Good to have you in now as well. Good job, Unesi. Thank you. And don't forget, guys, if my screen is taking up part of your screen and you're having trouble navigating, you can press escape. If it's full screen, and it'll allow you to get around easier. Good, we got 11. I think we've got 17 total right now, or 16. Or you say it would be 14. Still missing a few more. Quickly, guys, get in. Lag. Are you one of the ones that aren't in yet? Okay, we'll say about 10 more seconds, and then we're going to get started. So if you are one of the other 3 people, you just make sure to join in as we go, okay? All right, let's get started, guys. So again, this is basic probability and then a couple predictions. So do your best, and we'll see who is getting it. All right, champion. What is the probability of rolling a 6-sided die and landing on a 2? All right, we'll say 5 more seconds. 3, 2, 1. All right, let's see. You guys got 1/6. 9 of you guys got that correct. Excellent work. So again, the probability of getting a 2, right, would be 1 out of 6 total choices. All right. Oops. We'll get that on the next one. Looks like Pablo is in the lead. Bob 50 times. About how many times would he land on the 3? So if he rolls 500 times, about how many times would he land on the 3? By the way, if you joined us late, you can still go to kahoot.it and use this game pin here on a new tab to make sure you're joining with us. Good, we'll say about 5 more seconds. 5, 4, 3, 2, 1. Aha, uh-oh. Okay, but that is okay, because some of you guys are getting this all right. Just be careful here, guys. I was afraid more of you guys would choose red. So you're right, it's a 1/6 probability of rolling a 3 one time. But if he rolls it 500 times, then we have to multiply that 1/6 by 500. So if I said 1/6 times 500, hopefully you can see my screen here. That's going to be around 83 times, right? 83 and a third times. So that's why yellow is going to be your best choice. This is about how many, right? About 83 of those 500 times will be a 3. Okay, good. All right, next question. Uh-oh, some moves in the charts. Some of you guys are pretty quick. All right, let's keep rolling. We'll go through these a little bit quicker, so make sure you're ready. So if Joe rolls a die 40 times, about how many times will he land on an even number? Alrighty. Let's see what you guys got. All right, excellent work, guys. 80 of you guys got that right. Let's see, that is 8 out of 14, so it's still a majority. Good job. So yeah, we say how many times will it land on an even number? Well, 2, 4, and 6. That's 3 out of the total 6, so that's half, right? And then half times 40 would be 20. Good. All right, Preston takes the lead. Excellent work. What is the probability of rolling an odd number on a 6-sided die? What do you guys think? Odd number. Good. About 5 more seconds. All right. 9 was the correct answer. I mean, sorry. Red was the correct answer. 9 of you guys got it right. Yep, it will be a half. So there's odd numbers are 1, 3, and 5. So that's 3 out of 6, which is 1/2. Good job. Next question. Sarah rolled a 6-sided die 25 times. About how many times would she not land on a 3? Yeah, think about this one. How many times would she not land on a 3? So anything else but 3 would count as a correct roll, right? All right. So let's go ahead and check about this and talk about it. Good job. All right. Those 5 of you guys that got that one. So here's this one. It's just trying to test and make sure you know basically what's going on with a die, right? And how it works. So it says, what is the probability of not getting a 3? Well, let's think about that. If there's 1 through 6, right? 1 through 6. That's 6 possibilities. And it says, what's the probability of not getting a 3? So would a 1 work? Yeah. Would a 2 work? Yeah. Would a 3 work? No, because we're trying to not get 3, right? But a 4 would work, a 5 would work, and a 6 would work. So that's 5 out of the total 6, right? That would work. We just cannot get a 3. So 5 out of 6, the probability, okay? And then we multiply that by 25 times. So we would say 5 divided by 6 times 25. And we get 20.83. The closest to that one would be yellow, okay? Blue is very close, but it's going to be closer to yellow. All right. Good job. Next question. It's a tricky one. Spencer rolled a die 100 times. About how many times would he land on a number less than 5? So again, you have to think about what numbers are less than 5. 6 wouldn't work. 5 wouldn't work. So it has to be 1 through 4. Yes, Callan, just as far as, not for a grade, just as far as participation. So when I let them know how many people participate in the class. All right. Let's get our last few to respond, see what you guys get. You guys are doing excellent. Okay, about 5 more seconds. All right. Again, we want to try to get everybody's response, so make sure that you're A, playing, and B, responding. All right. Yep. Yellow is correct. So the probability of landing less than 5, right, would be 4 out of 6, right? So we would say 4 out of 6, and then times 100. Okay, so we would say 4 out of 6, which is 2/3, times 100, because that's how many rolls he did. So about 66.6 of those rolls should be less than 5. So 67 is going to be the closest answer. All right. Hopefully we'll see more and more of you guys get these correct. They're throwing some tricky ones at us. All right. What is the probability of spinning a 6 on this? Just one spin. What's the probability of spinning a 6? Good. You guys are quick on this one. Good. I spin a little spinner and it goes. What's the probability of landing on 6? All right. Excellent job, guys. 13 of you guys got it right. Almost everyone. There's our leader so far. See if someone can overtake him. If Susie spins 30 times, how many times would she land on a green space? So same spinner, but she spins it 30 times. How many times would she land on a green space? All right, about 10 more seconds. Okay. Ooh. All right. 9 of you guys got that right. Good job. So the probability of getting on the green space would be 1 out of 6, right? And it's ironic they chose 6. I feel like they should have chosen something else. But just because a die has 6 sides too. All right, so what we did there, right, is we took the theoretical probability of landing on that and multiply it by the number of trials, right? Number of spins. Good job, guys. Ooh, Preston making moves. Good job. If the spinner is spun 75 times, how many times would it land on an even number? I know it is not green. Spoiler. What do you guys think? Okay, about 15 seconds. Good. All right. Let's see what you guys got. Excellent job. Most of you guys got that one right. Again, even number, that's going to be 2, 4, and 6. So that's half. And then 1/2 times 75 times. Good job. I think you guys are really starting to get it. All right, we're going to go faster on these. About 20 seconds for each. So I want to make sure you guys have time afterward. What is the probability of landing on purple or yellow? One spin, purple and yellow. Quickly get your answers in. What is the probability of landing on purple or yellow? 10 seconds. 4, 3, 2, 1. All right, so the probability of getting purple or yellow, that's 2 choices, right? Out of the total 6 that would work. So 2 out of 6, or 1/3. And that's what our answer is there. All right, next question. If the spinner is spun 1,000 times, about how many times would it not land on red? So yellow would work, green would work, orange would work, blue would work, purple would work, but not red. Can't use that one. Good. Five. Say about 5 seconds. 3, 2, 1. All right, good job, guys. About 833 times. We take the probability, multiply it by the number of spins. I think you guys are getting it. Last few. Once we finish this, guys, I'll look what our assignment is for today, and then we'll be done. Kyra flips a coin 50 times. How many times would the coin land on tails? And again, approximately, right? It won't be exact. Take your probability of getting tails, multiply it by the number of times. 8 seconds. 4, 3, 2, 1. All right, 7 of you guys got it right. The correct answer was 25. Okay, because the probability of getting a tails, heads and tails, so that's 1/2 times 50 gets you 25. Okay, good job. All right, what is the probability of flipping the coin and it landing on heads or tails? So if you flip a coin, what's the probability that it'll land on heads or tails? It's a tricky one. Five seconds. 4, 3, 2, 1. Okay, that's a tricky one. So if you're flipping a coin, there's only 2 options, right? There's just heads or tails. So the probability of getting a heads or a tails is going to be 100%. There's no possible way to not get a heads or tails because that's the only 2 options. So if we said Probability of getting heads or tails, that's 2 options out of a total of 2 options. 2 over 2, guys, what does that simplify to? 1 whole. Oops. Okay, 1 whole or 100%. 100%. So we could have said 100%, or in this case, they wrote the 1. Okay, that means full possibility. Okay, it's gonna happen. There's no doubt, no shadow of a doubt, it's gonna happen. All right. Last 2, if Emma picks 20 times, how many times would a red star be picked? So probability of picking a red star, multiply that by how many times she's picking, right? If she puts it back each time. Good. Make sure you get your answer in. All right. All right, let's get a few more. Make sure you get your answer in. 5, 4, 3, 2. All right, 1. Let's see what you guys got. 4, you guys got it right? Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 stars. Probability of getting a red star, that is 2 out of 10, right? 2 out of 10. Then we take that and we multiply it by the number of picks. She does 20 picks, 20 draws, and let's see what we get. So 2 divided by 10, that's 0.2, 20%, times the number of draws that she does. She draws 20 times. So about 4 of those times, she should get a red star. So green's the correct answer. All right, and last question for all the points. See who are the champions. If Austin picks 30 times, how many times would he pick a green or yellow star? So a green star works, a yellow star works. Either of those will work for our answer. Last question, guys. Everybody in. Good. Keep them coming, guys. Keep them coming. Let's see who's got it. Let's say about 10 more seconds. All right. Let's see what you guys put. Ooh, again, not as strong as I was hoping. So how many times would he pick a green or yellow star? Well, 1, 2, 3, 4, 5. There's 5 stars that are either green or yellow out of the possible 10. So then we can say 5 out of 10 is the likelihood of doing it once, of drawing a green or yellow star one time. And then we multiply by how many times we're doing it, 30 times. All right, so that would give us a half times 30, so our answer should be 15. All right, let's see our champions. Thank you, guys. I know we're getting close to the other class, but we'll be done here in just a sec. Cadence in 3rd place, Preston in 2nd place. Good job. And Unesi for 1st place. Excellent job, guys. Runners up, I'm Boyd and Pablo. Great job as well. Everyone else, thank you. So Excellent job, guys. So just make sure this is your assignment for today, okay? Make sure that we're getting caught up on the this probability and make sure we're understanding it. You guys were doing very well. Just make sure that, again, at the tail end of the Kahoot, we struggled a little bit. So that's why I want to make sure we get this. I'm going to have a quizzes that I want you guys to do. And if you did not finish the 2 probability practices from the other day, from Monday, DD5 and DD6 to 80 SMART score, we had no quizzes that day. We just had this for our assignment. That is your assignment for today and tomorrow, okay? Is if you didn't finish these 2 to 80, make sure you do that because those go on your grade. And then make sure that this quizzes that I'll post here in a sec, you do as well.